Let's see if I can fix up this hot mess. Warm up the CRT, it's time for another episode. Did you know that 75% of you watching right now are not subscribed to my channel? That's bonkers. Engagement is what makes or breaks a YouTube channel, and I need your help. Subscribe today, and let's build a community together. Welcome back. So on the bench today, we've got the Applied Engineering ZRAM Ultra 2 card. This card was sent to me by Javier Rivera. We all know who he is, of course. He's like, hey Joe, do you want a challenge? Do you want to try fixing this thing? It's an absolute mess. I'm like, okay, yeah, sure, I like a challenge. And so he sent it to me, and it is a challenge indeed. So I'll tell you what has happened to this card. So the Applied Engineering ZRAM card is basically, it's a combination of a RAM card and a clock chip, or a clock card. And the battery here has decided to explode and destroy all the traces. We've seen that happen before. And it's absolutely annihilated. Let's get you a close-up look at some of the destruction here. We'll start on the front of the board, and we can see there's just crusties everywhere. This in here is really bad. You know, the chips got crusties on it up here. The sockets, you know, you can see the green nasties in there. And then I'm going to flip this over, and yeah. So the basically the corrosion got up onto these pins and ate past the gold plating, which gold is pretty unreactive. It shouldn't really have got destroyed, but there was just enough scraping there to where the alkaline or whatever was able to get up in here and corrode those pins, and they pretty much all snapped off on this connector. Of course, that's the connector that's closest up here to where the battery is. So yeah, we're going to have to do a lot of work. Now, it looks like somebody has tried to fix this before, because it looks like there's a lot of corrosion or a lot of destruction that happened on these circuit pathways here, these traces. And if you look in really close here, we've got traces here that are bridged that don't need to be. A lot of these sockets here, and these are where the RAM chips go, a lot of these sockets have the pins still in them, so they're going to have to be cleaned up and removed. And oh man, this is going to be a mess. Now, I am pretty certain I'm going to be able to make this guy work as a RAM card, no problem. The clock circuit here is going to be a little bit more difficult. I've got to find a battery that works for it, that I can mount off board somewhere, so that, you know, we don't have this problem again. But the issue with the Apple IIc, which is what this goes for, is there's really no room in there to put a battery safely. So, you know, I may make a connector here, so if somebody wants to add their own battery, they can do that or whatever. Additionally, I've got to replace this chip. This is an Okidata clock chip, or an Oki clock chip that I've got to find somewhere. That's going to be a challenge. Also, the trimmer pot here for the clock circuit is just, it's all crusty. It's all crusty to forever. And I don't know if that pot, or I think it's probably a trimmer cap. I don't know if that's going to work. I don't know if the resonator crystal there for the timing reference, I don't know. I have no idea. This section for the memory, though, is going to be pretty easy. This is the MPU and CPU, or the MMU and CPU that come out of the Apple IIc. That's not going to be a problem. I'm going to have those. These chips all look fine, too, as well. The GALs here, the GALs, the gated array logic, the custom logic that does the magic here, those look okay, too. And the upside is I can probably get replacement chips if they're not okay, because the GAL equations have been dumped by some awesome people in the past. So I can, if I need to reprogram it, I can. And this chip here, which is unmarked, is actually just a standard logic chip. I don't remember, it's like a 74LS173 or something like that. It's a weird logic chip, but you know, I mean, that's the crustiest chip right there. You can actually see green nasties on it. But if this chip's failed, I can just yank that chip out and replace it. But we've got a lot of stuff that we need to do to get this thing up and running. Well, I know where all the chips go, so I don't have to worry about really marking them. I know what all the chips are, so that's no big deal. But the first thing, or really the sequence of events we're going to need to do is I want to do a preliminary cleaning and see if I can get a lot of this crust off the board first. depopulate all of the chips, then depopulate all of the sockets wherever possible, because, you know, especially on the back here, these pin headers are going to have to be replaced anyway, so I'm going to yank all those out. I'm also going to document, there's a couple bodge wires, because this looks like it's an early version of the board that needed some modification. There's some bodge wires, some fly wires here going. I want to document where those go as well. You know, and they kind of fly under here and go, it's weird. Just because as I'm cleaning this board, they may break, fall off. I want to know where they go. Then after the board is completely unpopulated and all the sockets are out, then we've got to go through all of these traces, every single one of them, and check them all to see if they work. We also have to go across the back of this with a fine-tooth comb, and again, check for, this one's the most obvious one, but check for any of these traces that have been bridged that don't need to be bridged. I think this is one right here as well, and those need to go away. And then after all that's done, we can put our sockets back in the board, put our chips back in the sockets, put this into an Apple IIc and see if it works. So that's the plan. Let's get started. All right, first, let's get these chips out of here. Just pop them on up out of there and kind of, I'm going to put them on the foam here, kind of in the order they come out of the machine, or out of the device. Just as a mnemonic for me, because I'm a forgetful dude. Wow, look at the crusties under there. It's awful. But we will be taking care of that very soon. So those are the two gal chips. This is a 7.4 LS32 or something like that. Yeah, these chips down here look pretty clean. This is a 7.4 HC393, which if memory serves as a buffer or a register of some description. That goes there. Get this chip out, which is 7.4 HC04, which is an inverter. It goes there, and then this 7.4 LS245, which I definitely know is a buffer or a bus transceiver. Okay, all of the chips are out. So now let's, next step is I need to get my toothbrush and a cleaning solution of some type and see if we can get some of this preliminary gunk off here. What I'm going to use for this is basically just isopropyl alcohol right now. I'm trying to remove as much of that just actual crap out of the way before I try to neutralize anything. So let's do that. Put it on some paper towels here so I don't make too much of a mess. Got my isopropyl. Just soak the crud out of it. Now we scrub. Basically, again, I'm just trying to get down in here and get as much of the crust out of the way as I can. And also using isopropyl because it evaporates quickly and it gets out of my way pretty quickly. I also just happen to have it in a squeezy bottle. I have it at hand, so, you know, it's easy to keep around. And I can tell, oh yeah, this stuff stinks. Oh, the water, the liquid in the isopropyl's reactivating it, and it's all vaporizing, and I can smell it, and it smells like a bottle of aspirin. Have you ever sniffed a bottle of aspirin? Go do it if you have a bottle. Don't inhale it, but just kind of sniff the bottle of aspirin, and then you'll know the smell that I have permeating my lab at the moment. So we're just going to dig in here and get this all done. Okay. I want to get in all these sockets too. Now I'm also going to flip it over and do a little cleaning on the backside because we know the backside is bad as well. Being very careful around these bodge wires. I don't want to break them loose because I want to know where they go. You know, I need to remember where those bodge wires go because I'm going to have to ensure that they're put back in place when I'm done. Okay, now while this is still wet, I'm going to hop over real quick to the sink and I'm going to hit this with water and just get all the crud rinsed off the board. I'll be right back. And we're back from a nice hot water bath, And I got a lot of the crunchies out of there. I mean, it's still not perfect, but a lot of them are gone. So step next is I'm going to work on depopulating the board. I want to get these sockets. I want to get these sockets out of here and just get them out of the way so I can get really close to the components with the next step after that, which is a little bit of vinegar to actually eat into this corrosion and neutralize any of the alkaline or whatever that came out of this battery to get that thing situated. So we're going to do that next. What did I tell you? Those pins are just snapping off the bottom of that thing like there's no tomorrow. Okay, we have all the nasty sockets removed, so the next step is to really get in here with some vinegar or a similar solution, similar acidic solution, and see if we can get rid of all of the remaining corrosion on this board. Coffee time. All right, boys and girls, it's science time. We're going to drain the vinegar out, rinse everything with water, then I'm going to put a little bit of baking soda in the bottom of that container and dissolve it, and then soak the board in baking soda water to neutralize any leftover vinegar in there. But before we do, because science, I want to see what happens when we do this. Just a little bit. Ha 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 ha! Nerd stuff. So let's do it. See that? The board isn't clean until the vinegar's green. So there we are, a cleaned and dried board. All the crusties are gone and still looks kind of but you know, it is what it is. We're dealing with 30-year-old hardware. So the next step here is to go through all of these plated through holes, these vias as they're called, make sure that they're all good, make sure none of the pads are missing, remove the little pins that I can feel still stuck in the memory locations here, test any traces that look weird, look on the back, check for any cross connects, any shorts that aren't supposed to be there. Check all the just everything. I need to check the capacitors as well for shorts and the whole 9 yards. So I'm going to dig into that right now, and if there's anything important, I'll bring it back and show you. Here we are, board all cleaned up. Got a lot of the crud all out of those, and those little bits and pieces of pin that were left in those, all gone. I also depopulated all the capacitors here because I wasn't sure if they were good or not, and you can't really test capacitors in circuit because the capacitors of all the capacitors add up, and then you can't really test them that way. I did take those out, as you can see them laying over here, and they all tested good, but I'm probably going to replace them anyway. No big deal there. As you can also see here, those fly leads they had to come out. I had to get them disconnected in order to clear out the pin holes or the through holes here. So that's no big deal. I'll just have to look back at my documentation, find out where those go, and put them back in place. I went ahead and tested all the resistors on the board. All the resistors test good, no problem there, with the exception of this one up here. This one actually snapped off when I tried to test it, so I went ahead and replaced that. It's like a 56K resistor, no big deal. And there was also, you can see some red marks I have here on the board there, blah, blah, blah. Those red marks all indicate places where traces actually failed on the board. These couple places of the entire pad and pulled up and the trace pulled back. So I'm going to have to basically stuff a 30 gauge wire down the hole and run it back to where it's supposed to go and solder that in place. I have to do that in a couple different places. This one right here, actually the trace is cut through right in this general vicinity and just doesn't make it to that pad or the rest of the way back. So here what I'll probably have to do is scrape it down a little bit and put a little blob of little film of solder across that to reconnect that. No big deal. Negative terminal of the battery, toast. Positive terminal up here, also toast. But the thing is that everything from this side of the board over, all of its positive connections actually go right through that via hole, which means nothing on this side of the board has any connection. So I'm going to have to tap through here, run it through the hole, bring it to the back side of the board, and connect it to the positive bus down there somewhere, somehow. Anyway, no big deal. That might actually be negative, but I'm pretty sure that's positive. It doesn't matter. It's disconnected here. It has to be connected. Flip side here, the back side of the board was actually pretty good. Lots of traces that were cross-connected in this mess, got all that cleaned up. And there's only one bad trace. It's between this pad and that that via or through hole right there. No big deal there. Again, just stuff a piece of wire down through there when I solder the socket in, and then we just solder that to that pin there, and that'll recreate that trace. Also, one little exact same thing up here. There's no connection between this via and this thick trace here, even though it's supposed to be there. So again, a solder blob or something there will take care of that and go connect that together. Easy stuff. So with that said, it's time to start repairing all those little glitches and to start stuffing sockets back in the board. We got a lot of sockets to stuff. Of course, these are all the ones I took out, but somebody who came in before us had taken all of those out, so I got to stuff all those as well. So let's get to that. I wanted to show you a trick here for repairing broken traces. The trace between this pin and this pin has been lifted from the board and is completely gone. It's not there anymore, so we need to recreate that. So what I've done is I've taken a 30 gauge wire, like a wire wrapping wire, removed the insulation from it and stuffed it through both of these holes, and then kind of routed it up out of the way because this is a bare wire now, so it won't touch things that it shouldn't touch. And then the next step that you do is you take the socket that you want and you put it in the socket placement in the holes here. And what happens is the socket will kind of hold the wire in place. And so then you flip the board over, and you would solder a couple of pins on the socket, but not the pin the wires go through. Once the socket is tied in place, then you can take this wire, fold it up, and snip it really close. Now the reason why you don't want to solder this pin first is, for example, in the case of this one over here, because this thing is flying off to wherever, this can wick up solder and then cause a bridge between this pad and this trace here, and that's not something you want to do. So you basically you affix your socket so that it doesn't fall out, trim your leads down, then solder the whole socket in, and that replaces that broken trace there. Now here's a test jig that I set up for that chip that was in the upper right corner of the board that looked all green and crusty. And I looked that up, and it is a 74LS173, which is a quad latch, a quad 1-bit latch. Basically, it's got four data inputs and 4 data outputs, and the series of select lines, and then a clock line to clock the data from the input side to the output side. So no big deal there. So what I've done is I've hooked up my little slow clock to it and tied all the proper lines so that I can test the outputs of the latches to ensure that the data coming in from the input side actually latches to the output side. And lo and behold, the very first input, this input right here, 1Q, is positive no matter what. If I ground it, it's 5 volts. If I put 5 volts to it, it's also 5 volts. It never actually clocks data across. It's fried in the high position, whatever. So what's happened is that alkaline has gotten up under the pin here, soaked into the package, and destroyed the package, and it's either shorted something across or killed a bond wire or something to that effect and has destroyed that chip. So I'm glad I tested that and figured that out before putting the whole board back together and realizing things don't work correctly. So I'm going to go ahead and make sure that when I put the board back together, we put the new chip in there. Here we are. I have the 74LS173 chip reinstalled, or the new one installed there. I've also installed the M6342 clock chip. I had to go online and get that because, of course, the original clock chip was completely missing, but we put a new clock chip in there. And the same with the RAM. I bought an entire new set of RAM from one of my favorite sources and have completely populated the board with RAM. Now, I'm still using these original GAL chips and these original chips over here, and these chips may or may not be good, but you know, what are we going to do to test those until we plug it in to find out and see what happens? So let's go ahead and get the CPU and the MMU populated into this board, and that's pretty straightforward. You just pop them out and put them in those sockets. Start with the CPU here. Well, how about I put on my anti-static? Let's do that. Okay. CPU is installed. You can come out. There we are. Check the pins. Pins are all good. Yes, so we'll install the MMU. All right, so it's fully populated. All we need to do now is put the board in the Apple IIc here and see what happens. So we'll remove my protecty stuff on off the bottom there. Well, this is a little footery, so this will take a little effort to get this aligned correctly. There we are. There it is, fully installed. Now all we got to do is turn it on. Did it work? You're going to have to check the next episode to find out. Thanks for hanging out with me today. Remember to like, subscribe, and ring the bell to stay up to date on my latest adventures. You can also support me through Patreon or by grabbing some merch. Links in the description. Well, that's all for today's episode. While you're here, check out some of my other videos, and remember, 8 bits are all you need.